Hello and welcome to Cruising Through Calculus. My name is Alex, and today I wanted to talk about a misconception that a lot of students have about simplifying with radicals. If you ask students to simplify the square root of x squared, for example, I think that most people would say the answer to this is x. But as you can probably guess, this is actually not correct, which is a little weird because this is probably what you've been doing anytime you simplify a variable raised to a power when you're finding the radical of that variable raised to the power. Let's see if we can figure out why it's wrong, though. Very often when you're solving math problems, there's more than just one way to solve them. But no matter how you approach solving a problem, you should get the same answers in the end. Let's try that over here. We're going to try two different versions of figuring out what the square root of x squared should be equal to. If the formula here was correct, we should get the same answer as the other method, and you'll see what I mean by that in just a second here. First though, I want you to think about the formula a little bit. The square root of x squared equals x means that whatever I pick for x here is going to be just the answer. So let's say we pick negative 3 for x. Well, if I'm following the formula here, my answer should be negative 3. Let's approach it a different way though. Let's still pick negative 3 for x, but this time what we're going to do is we're going to follow the order of operations. So when we do negative 3 squared, well, negative 3 squared is 9. And then the square root of 9 is 3. Wait a second. Negative 3 and 3, those are two different answers. That means that something is wrong here. What's wrong is the fact that the formula isn't taking into account the fact that you're squaring a number. You see, when you square a number, it always turns positive. So here, when we take negative 3 and square it, it turns into positive 9, and that's what we take the square root of. The formula, though, doesn't take that into account at all. It just assumes that whatever you pick for x is the answer in the end here. That doesn't mean that this formula is worthless, though. In fact, this is true as long as x is greater than or equal to 0. Or maybe another way of saying it is that the formula does work if x is 0 or x is a positive number. Which begs the question, what is the correct formula that will work no matter what x value you pick, positive or negative? Well, I'll show you. It's actually just the absolute value of x. In fact, why don't we test it right now and come over here and use the correct formula and compare that to the order of operations that we did from before. All right, I've got the correct formula written up here. Let's go ahead and do the same thing we did last time and pick negative 3. Now, we're just going to follow the formula. According to the formula, the square root of x squared is equal to the absolute value of x. And I just picked x to be negative 3. So that means this is equal to the absolute value of negative 3. And if I take the absolute value of negative 3, I get 3, which is the same answer we got when we did the order of operations. This is incredibly helpful to know, especially in calculus, because there are certain problems where you'll be simplifying square roots, and when you simplify them, you need to include absolute values. Otherwise, you won't get the correct answer. There are a couple of other things to talk about too, so let's take a look at those. Let's take a look at these problems here. Okay, the square root of x squared, remember, is actually the absolute value of x, because we need to make sure our final answer is positive. Okay, that means the square root of x to the fourth might be x squared with absolute values, right? Actually, no. Because x is being squared, that makes this positive, which means that if we include absolute values, that's really unnecessary. So you don't need absolute values if your final answer is being raised to an even power. Good to know. Let's try this one here. The square root of x to the sixth, that's x cubed. Now cubed is an odd power. That means that we need to put absolute values here because we need to ensure our final answer is positive. What about the square root of x to the eighth? Well, that will be x to the fourth. And there's no need for absolute values now because x to the fourth will always be positive. Let's take a look over here at our cubed roots. The cubed root of x cubed is x. The cubed root of x to the 6th is x squared. The cubed root of x to the 9th is x cubed. And the cubed root of x to the 12th is x to the 4th. But wait, what about the absolute values? I didn't put any in when I was doing any of these problems. Well, that's because you only have to worry about this absolute value thing if you're taking the square root of a number. If you're doing the cubed root of a number, you don't have to worry about that. That's because cubed roots do allow negative answers, whereas square roots do not. Now in my two examples here, I'm using square roots and cubed roots, but it doesn't have to be a square root or a cubed root for these ideas to apply. For example, over here, it could be the 4th root, the 6th root, the 8th root, or the 10th root. If the index on your radical is an even number, you have to worry about the absolute values. But if you're taking the cubed root, the 5th root, the 7th root, the 9th root, in other words, if the index on your radical is an odd number, you don't have to worry about absolute values. Also, you only do have to worry about absolute values if the final answer gives you an odd power, because even if you take a negative number and raise it to an odd power, that's still negative, and you need your final answer to be positive. Let's take a quick look at an example. If we take the square root of 25, our answer will just be 5. Notice our answer is not negative 5, it's not even plus or minus 5, it is just 5. That's because when you're evaluating a square root like this, you're always assuming that you're going to take the positive answer here. This is different than, say, this right here. X squared equals 25. If somebody gives you this problem and they say find all x values that make this true, you would indeed take the square root of both sides, and then you're going to get your plus or minus like this. Now, those of you who are paying very close attention may notice that when I did the square root of x squared, I did just write x here, instead of the absolute value of x. Well, that's because I have the plus or minus 5 over here. In fact, check this out. If I take the square root of both sides of this like I did last time, I can still use the absolute value of x, like this. These are both the same thing, because there are two numbers that you can plug in here for x to make it equal to 5. One of those, of course, is just 5, because the absolute value of 5 is 5. And the other is negative 5, because the absolute value of negative 5 is still 5. So if you're solving an equation, you can also use what I told you before. The square root of x squared is the absolute value of x. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.